Hello friends and welcome to a lecture on operation research. Today we will do a very interesting lecture. We will we will solve for the shortest part in the network using Microsoft Excel. I am Professor Arvind Prasad. Now let's take a network. Now this network might look very simple and finding the shortest path from O to T is fairly rudimentary. I know all of you would be able to solve it. But we will take this as an example in Excel and try to solve it so that we can at least get the algorithm conveyed to you in a very effective way. Where does this help? Let's take up this network. Now, this network is fairly complex for anybody to solve it in the examination also, given the time constraint, and otherwise too. You are prone to make errors here. Why? Because the network is a bit complex and you have a lot of numbers here, a lot of connections here, and there is every chance that you might get lost. So it is better to use computers. Remember one thing, I have already in my previous lecture also always put this across to all my students that if it was not for computers, we would never have seen operation research being implemented in industry and corporate in such a large way. It is only because of computers that operation research algorithms are used effectively to solve fairly complex problems. So one should know how to use computers to solve any problem in operation research. So let's get to our Excel file. Now we have the open Excel file and the network on the screen. I have copied down the network only for reference so that we can solve the problem. You need not actually do it. Okay, now just follow what I'm doing. So let's take this network here now and place it at a convenient position. Now, what does the network have? I have already zoomed it to 150. Yes, what does a network have? A network has nodes and the network has arcs. OA, AB, BC, they are arcs. And O, A, B, the ones in the circle, they are nodes. So the first thing that you have to do while solving in Excel is you have to make note of the arcs. So the arcs are always going to be from to, that is from O. If an arc is going from O to A, it is from O to A. So we make a note of the arc by writing from and to. So from O, we have an arc till A. Also from O, we have an arc till B. Then from A, we have an arc to B. Now, since this is an undirected network, you are also going to have a node direction which is from B to A. Okay. Now from B, okay, oh, so that would come later on. Anyway, I'll just copy this. Okay, from A, you also have an arc which is going towards C. Then you have from B, an arc which is going to A, the reverse one, and B to C. Okay. We have taken B to A, as just explained earlier. It's an undirected network, so you have the arcs going in both the directions. Okay. Then afterwards, from B to C, I have noted. Then finally, we have from C to D. Right. And now let's load their lengths, which is nothing but the distance. So DIS. That's it. So O to A is 4. O to B is 6. A to B is 1. And A to C is 8. And then B to C is 5. So B to A is also 1 and B to C is 5. And C to T is finally 9. Okay. So this, whenever you type T in Excel, 2 automatically is taken. So you have to make that correction there. Now we pretty much have we have made a note of all the arcs that we have in our network. Now we'll introduce an idea, something known as en route here. Okay. Now, supposing OA is a part of the shortest path from O to T. Okay. Its en route value is going to be 1. Now, let us suppose AC is not a part of the shortest path problem. Its value is going to be 0. Its en route value is going to be 0. Now, when it's a very complex network, we don't have to select this. Excel will automatically do it for us, and I'll demonstrate in a little while how does it happen. But once the en route values are selected, the en route value multiplied by the distance and the sum of all such en route values which have a value of 1 is going to give me the total distance, right? So to start with, let me take all en route values as 0. Okay. Total distance is going to be nothing but equal to sum product, the en route values multiplied by the corresponding distances. That is what sum product does. And now it is 4. Now question is, how do we select how does Excel select the correct en route values? Remember, when it's a very complex network, things can happen in a jiffy. So how do we program Excel to do this? And remember, any program even written in Python or any other language will have to necessarily follow the same logic which I am showing you here. So the next part of the logic is going to be, we are going to define something known as node. What are the nodes here? The nodes are O, A, B, C, and P. Okay. And in and out. As explained to you earlier, if OA is a part of the solution, right, its en route value is going to be 1, which means the node value of O is going to be 1, and the node value of A also is going to be 1. Okay, so let's capture this information. So we write sum if for this, and we select from here. Okay. So if a node is going from O, okay, from O to A, it is a node which is going to flow out of O. So I'll have to write this formula in out. So I'll write it as sum if of any arc flowing from out of O, or from node O, any arc which is flowing out. So for that we write sum if, and then we write from, we select this, and then we select the node value, and then we select the en route value. Okay, and we give these absolute references. That is the B and the D cells, we give it absolute reference. Now, as you can see here, what has this done? Now, from O to A, that is any arc going from O to A, Okay. The out value of that is O. That is the out value of node O is 1. Why it is 1? That is because the node is going, or the arc is going from O to A, and node A is involved in it. So OA is going out of it. Its value is 1. The node en route value is 1. Okay. So that makes the sum if value as 1. Now we make sum if for n. So for n, we select the two values. Then we select the node value. And then we select the en route value. Okay. There we are. F4, make it absolute. And F4, make it absolute. Now, as you can see here, in value is 0. Why? Because OA flows out of node O. Okay. So the node O value for this is going to be 0 because A is not involved in it, and out it's going to be 1. Okay. Now it will be very clear to you if I copy this formula down. Okay. Let us say a part of the solution, OA is one part of the solution. Now AB is one part of the solution. Now what does this exactly do? Okay. AB is one part of the solution. So OA is one part of the solution and AB is one part of the solution. So the total distance you have is 5. Now out is going to be 1. And for A, okay, because OA, so node A, in is going to be 1 because in node A, you have a arc OA which is coming in. So 1. And then in node A, you have a arc which is leaving also. So its en route value is also going to be 1. So you have 1 and 1. Now what we do is we take the difference of this. So the difference is taken as such that you take what is coming in as negative. Okay. So what is coming in is taken as negative. So what we do, and what is going out is taken as positive. So we select the out value first, minus 1. And there we go. Okay. Now let's copy this down. This is the difference. So this is known as conservation of nodes. And it's a very basic idea in network. In shortest path problem or in maximum flow problem or a minimum cost flow problems, that is the flow coming into the node is equal to the flow flowing out of the node. This is a very important concept in network, and the same concept is something that we have used here, but it's done in an Excel form. Now we write here supply demand. Now let's remember here, in node O, there's only one arc which is going out and its value is going to be 1. But if we take the difference of out minus in, okay, where in is going to be negative and out is going to be positive, so its value is going to be 1. Okay. Now finally, if we come to node T, you have only one arc which is coming in into it. Okay. Now in is something which you are going to take as positive and out is something which you are taken as negative, right? Let's have a look at here. Out is something which you have taken as positive. Out is something which you have taken as positive, and in is something which you have taken as negative. Okay. In is taken as negative. So this value is going to be minus 1. Right? And the rest of the values by the law of conservation is going to be 0. Okay. Now we can begin to solve the problem. So we can go to solver And this is some previous work I had done. So I'll just cancel all this off. So reset all, reset, and okay. So we select the value of this. That is the total distance. We want it minimum by changing the values of en route. And then we have to put the constraints here. So we put add here. Now we select the constraint. This constraint is difference should be equal to supply demand. So there we are. We take supply demand. And there we are. We add it and we are done. So we use the simplex method here and we click solve. And click OK. And as you can see here, we have got the solution here 19. And it is indeed 19. OA, AB, BC, and CT. That is 4 plus 1 makes it 5. 5 plus 5 makes it 10. And 19. This is indeed the shortest path. And this is what Excel has also found out. Now, isn't that a great thing? Now here, remember the beauty of doing all this is you can change the distances and try various things. And you can each time ask Excel to solve it and it will solve it for you. And if it is a far more complex problem, remember one thing, with the click of a button, once you have set it up, with the click of a button, it's going to solve it out. Right? So the minimum distance here or the shortest distance here is 19. And what are the routes selected? OA1. It also gives you what are the routes selected. So OA1, AB1. So AB is the next route. Then afterwards BC. BC is the next route. And CT is the final route. So you have OA, AB, BC, and CT. So you have your answers here. Fine, friends. So this is all how you solve the shortest path problem in Excel. Okay. Next, I will demonstrate how we do a very complex problem in Excel, how we solve a very complex problem in Excel. And then you will really understand the beauty of this, that how Excel actually solves a very complex problem in a very short time. And therefore, you can actually use it for your project work, where you can take fairly large complex networks and find the shortest path, find the maximum flow. I'll be discussing all this one by one. It will be coming in a series of videos. How do we use Excel to solve network problems? Okay, but why was this video so elaborate? The reason is I wanted you to understand the fundamental. Now, the fundamental that I have shown to you here, or the algorithm that I have shown to you here, is the algorithm which is going to be common to all the programs that have been written for networks, and it is common to all the spreadsheets that I will be demonstrating now onwards. Okay, it will be common. So you will have an idea of why I am doing certain things. What is the basic idea behind it? The basic idea is A, make a note of all the arcs. Second is conservation of node. Okay, the right hand side of the sheet is nothing but conservation of nodes. And using these two very powerful algorithms, you can solve any problem. So that was all, my friends. Goodbye, friends. Have a great day and have a great time too. And I always find that people who are watching my videos, they really do not subscribe. So I would request you to subscribe my videos. That keeps me a bit motivated. And do share these videos with your friends if you find it useful. That will increase the viewership of it. And of course, it will get this video to a larger audience. So friends, goodbye.